so here, grouping like terms, we have 3x, if this comes here, minus x plus 4 equals 9 minus 3 is 6 plus 6 root of x minus 3. So at the end, sorry, this one is minus x. You know, when this one comes here, minus x plus 4. Okay, so we have 2x plus 4 minus 6. I've brought 6, this 6 here equals 6 root of x minus 3. So at the end, I have 2x. This minus this will give me minus 2 equals 6 root of x minus 3. And since I can factorize 2 out here, let me do it that way so it will be simple here. So we have x minus 1. You know, if 2 comes out, 2 goes here, 1, 2 is out. So equals 6 root of what? X minus 3. If I divide here by 2 and divide here by 2, this cancels that. I have x minus 1 equals, this goes here 3. So I have 3 root of x minus 3. I still have a square root here which I have to eliminate. So I have to square this and also square that. Now squaring this one gives me x squared, remember, plus minus 2x plus 1 equals 9. Remember, this one is not in the square root, so the square affects this. So 9 into bracket x minus 3. Expanding this, I have x squared minus 2x plus 1 equals 9x minus 9 7 21 9 3 27, sorry. Grouping like terms, I have x squared minus 2x minus 9x plus 1 plus 27. So I have x squared minus, this gives me minus 11x plus 28 will give me what? 0. Okay? And so this is supposed to give me let me check the particular answer for this. Okay, so this is supposed to give me x minus 7, x minus 4. Let me clean this side. So solving this one quadratic, x minus 7 and then x minus 4 equals 0. Okay, so 7 times 4 will give me 28, right? So which means x equals 7 and also x will give me what? 4. Are you okay? Alright, so let's solve one more example of this nature and then we'll come to a close on this episode. Let's take this particular question. I have root of x plus 7 minus root of 3x minus 2 equals 1. So let's solve this particular one. So of course, since I have to eliminate the square root, let me set this one there. That's easier for me. So it's negative. When you cross, it becomes positive. So 3x minus 2. If I square here and then square there, I'm going to get x plus 7 equals 1 squared is 1 plus 1 times this is the same thing. Multiplying 2 will give me 2 root of 3x minus 2. And squaring the last one is going to give me plus, it will cancel, so 3x minus 2. Grouping like terms, I have x and this comes here minus 3x plus 7. Let me move the 1 here, minus 1. If I move this 2 here, I'll get plus 2 equals 2 root of 3x minus 2. So at the end, this and this is going to give me minus 2x. If I subtract 1 from 7, I'm going to get 6. Now 6 plus 2 is going to give me 8. Equals 2 root of 3x minus 2. Since I can factorize 2 out here, let me factorize 2 so that I have this plus 4 equals 2 root of 3x minus 2. If I divide here by 2 and divide here by 2, I have minus x plus 4 equals root of 3x minus 2. So let me square here and square that. Since there's a square root, I have to remove that. So negative x squared will give me positive x squared. If I multiply this, this is going to be minus 4x times 2 will give me minus 8x plus 4 squared will give me 16 equals, this cancels that, so I have 3x minus 2. Grouping like terms, I have x squared minus 8x. If this 3x crosses, minus 3x plus 16 plus 2 equals 0. So I have x squared minus, this will give me 11x plus 18 equals 0. So at the end, I'm going to get x equals 2, so x minus 2, x minus 9 equals 0. X minus 2 and also x minus 9 equals 0. Which further implies that x is equal to 2 or x is equal to 9. Alright, so this is where we draw the curtain on radical equations. On our last episode on surds, we are going to look at finding the positive square root of a surd, and then we'll also look at some further questions involving surds. That's going to be our last episode. So thank you very much for watching. Until we meet next time, I'll say goodbye for now.